Hello, dear colleagues. Today I want to present you our work on the topic implementation of probabilistic data structure in the processes of neuroevolutionary synthesis. So let's start. In this slide, you can see the advantages and disadvantages of neuroevolutionary approach. Usually, when we talk about neuroevolution, we can say that this is alternativity approach for the synthesis of neural nets. And as any approach, it has some pros and cons. The main advantages it is using with different learning strategies, the high level of adaptivity, the parallelization of operation. But we have the list of disadvantages. And the many of disadvantages can be explained by the one. It is high level of resource consumption. And how we can solution it. Let's see at the next slide. Probabilistic data structures. Probabilistic data structures, it is very interesting group of data structures. We usually talk that we use in some hash functions for the coding of input information. And as a result, we have the hash of our input data. And what is more interesting, the last work on this topic demonstrates that we can compress our data for the 90%, for example, and this is really good result. So how we can implement the probabilistic data structure during the neuroevolution synthesis? Usually we talk about two cases. First case, it is sequential execution of neuroevolution, and the second case, this is parallel execution. In two cases, we usually talk about very similar implementation. This is coding of genetic information about individuals in our population. This will be the neural nets. And what is more interesting, when we talk about sequential execution, we can say that we will have some very interesting stages at the stage of mutation or some variation of our individuals, and at the stage of recombination, when we will selection some really the best solution for it. In the parallel system, we usually say that we can't use probabilistic data structure during we work on the threads or in the different course, but we can use it when we transfer data from the main or to the main core during the execution. In this slide, you can see the main probabilistic data structure which we will using during the work. This is Bloom filter, min hash, and count min sketch. This is well-known data structures with very huge background, which can be really interesting and useful in our work. So, compression of the probabilistic data structure for the work. As you can see, we make some compression, and I must say that min hash and count min sketch we will use during the sequential execution, and Bloom filter we will use in the parallel case. In the next slide, you can see some information of data set which will be using during the training, and some meta-parameters, because when we talk about neuroevolution approach, we usually talk about some meta-parameters which can changes. And we have some difficulties at this stage, because count min sketch and Bloom filter can make some changes in structure of coding information. But when we talk about min hash, we have some problem in this stage. So for the min hash, we will use only one epoch for the synthesis, the best solution. And in the case of using Bloom filter and count min sketch, we usually talk about the 5 epochs. In this slide, you can see the first part of result. This is using the sequential execution of evolution, and what we can see. We have really not a bad result of using memory. and the synthesis time really came more smaller. But when we talk about min hash, we must say that during the training, we have not bad result. But when we talk about the testing, the accuracy not so good. Yes, it can be explained that we use only one epoch for the synthesis, the best solution. But this is not so good. And what is more interesting and important, we have not so good synthesis time. Yes, it came smaller, but not so good. During using count min sketch, we have more optimistic result because accuracy not so bad. We really can see that very balanced using of memory, but the time in this case came more smaller, but not so good. So, we haven't got some balanced result. If we talk about the balance between the synthesis time, the accuracy of final neonet, and the using of memory during the synthesis. Bloom filter demonstrate more good result because in this case we must say that we have not so bad error. We have some not so bad result for the time, and communication overheads really goes more smaller, and this very important. But in this case, we must say that accuracy not so bad. So what we can say as a conclusion of all this manipulation? Yes, really. Use probabilistic data structure during the neuroevolution synthesis demonstrate not bad result and have some advantages. This is compact data storage and forwarding. This is really speed up during the compression of neural nets. This is really some level of optimization of using the resource. But we have the list of difficulties, and these difficulties can be explained by the one case. Really, complexity of coding and encoding the information about neural nets. In our case, the genetic information of neural nets. The question of coding and encoding the genetic information about the neural nets in neuroevolution, very important question. And in this case, we can say that we have problems because before the mutation and crossover, we must know the accuracy information about our individuals. And using probabilistic data structures can't give to us really accuracy information. So as a future work and in the future plan, we can use probabilistic data structures for the coding of information of pre-synthesis neural nets. So during the neuroevolution, we have the best solution and we must transfer it, for example, from the server to the other working station. And for it, we can use probabilistic data structure, because we will have really compact information about this neural net, and it can be transferred for another working station. It can be explained by the real good result of reduction of time of synthesis and reducing the communication overhead in parallel system. So this is final of my presentation. I want to thank you for attention, and your ideas will be welcome as a comments. Thank you. Goodbye.